Now, applications of Gauss's law. First, let's calculate the field due to infinitely long, straight, uniformly charged wire. Now see here, if we consider any point P which one is situated at perpendicular distance R from the wire, this one, okay. Now if we turn the wire, then this particular point P will be rotated and will form a circle having radius equal to R. But we can understand this thing, each and every point on the circumference of this particular circle having radius R, that is with the same symmetry as P, and electric field at each and every point that will be radially outward. If here this particular wire is positively charged and if it is negatively charged, then radially but towards the wire. See here how it will be radially. If we consider any two infinitesimal small wire elements which are at the same distance from this particular center, we can say, then at point P, if we think about the electric field due to both the elements, then electric fields will be in the directions as shown in this figure. But now if we take the components of this electric field, vertical and horizontal, then vertical components here parallel to this particular surface will cancel the effect of each other, and horizontal will be sum up in this direction. So resultant field that will be radial one. Here suppose the linear charge density of the wire, that is lambda, means charge per unit length of the wire. Now here if we consider the Gaussian surface, which one is a cylindrical one as shown in the figure, having radius equal to R and length equal to L. Then by applying the Gauss's theorem to this particular cylindrical Gaussian surface, one can easily calculate the electric field. Now, flux associated with this cross-sectional surface is this upper one and this lower one. That will be zero because their area vectors for upper one vertically upward, for downward vertically downward, but both the area vectors will be perpendicular to this radial electric field. Therefore, flux associated with this cross-sectional upper and lower surface will be zero. Now, flux passing through the cylindrical surface that we have to calculate. Suppose here we consider infinitesimal small surface element delta S on the cylindrical surface. Then its area vector that will be radially outward, electric field that is also here radially outward because our lambda that is greater than 0. So phi that is equal to E dot delta S for this particular element, and if we want to calculate the total flux, then we have to take the summation of it. So sigma E dot delta S will give you the resultant flux. Now E is same one at each and every point on that cylindrical curved surface, because each and every point on the cylindrical curved surface that is at the same perpendicular distance R from the infinitely long wire. So E sigma delta S cos theta, theta that is 0. So here we can write cos 0. So E sigma delta S, that is the summation of the area of each and every element of this particular cylindrical surface, which will give you total cylindrical surface area, and that is 2 pi r L. So we can write now flux phi, that is E into 2 pi r L. This one is calculated as per the definition of flux. But as per Gauss's law, flux passing through any closed surface, that is net charge enclosed by that surface upon epsilon 0. Okay, so here we can write now this particular charge enclosed by the surface, that is how much. So here charge per unit length of the wire is lambda, then charge on the length L, because here length of the cylinder under consideration, that is L. So charge enclosed by the cylinder, that is charge residing on L length of the wire. So we can write now charge per unit length is lambda, therefore charge on length L is how much? So Q, that is lambda into L. So we can write now E into 2 pi RL equal to lambda into L upon epsilon 0. L is cancelled. So E, that is lambda upon 2 pi epsilon 0 R. And in vector form, we can write E, that is equal to lambda upon 2 pi epsilon 0 R into R caret, where R caret is the unit vector in the direction of electric field. Clear to all of you?